Next up from Team Grad students, we're going to heat things up a bit with our presenter, Jeff. Doesn't need a nickname to sound like a SmackDown champion, Cannon, from the Peterson Lab. And he's going to talk to us today about crash and burn, interactions between forest wind damage and fire.
So my name is Jeff Cannon, and I study how forests are affected by wind damage and fire. And so disturbances like hurricanes and tornadoes and wildfires are really destructive and cause huge loss of life and property, as we saw with the Moore, Oklahoma tornadoes recently and the Arizona fires this summer. And so because fires can be so destructive, it's really important to the public as well as to ecologists that we understand what determines how these disturbances behave. Current research suggests that the way a disturbance behaves depends in part on what disturbances have occurred previously. So you may expect a wildfire to be really severe if just before the fire a tornado came, toppled lots of trees, and created lots of additional fuel. But fuel isn't the only important factor governing fire behavior. There are other important aspects like weather and topography that can have an impact, and other fuel characteristics such as the amount of fuel, the type and size, its moisture and arrangement can be really important as well. So what my research does is look to see how tornado damage can impact these fuel characteristics so that we can better predict how wind damage will influence a subsequent fire. So in order to do this, we've worked in a forest where we've done some simulated wind damage and a controlled burn, and we've found some pretty surprising results. So first of all, the most obvious thing is we saw a huge increase in fuel after the tornado damage, and that led to a really intense fire. But what was interesting was that the increase in fire intensity occurred for reasons other than what we expected. Yes, there was a huge increase in fuel, but most of that was in the really large size classes like downed trunks and branches that never actually burned. So if you exclude those really large size classes, the available fuel was actually pretty similar in amount between damaged and undamaged areas. What changed was the makeup of fuel. So you had a small increase in the amount of fine woody material and grasses in the damaged area. So that gives some explanation to the increased fire intensity. But what was really drastically different between the damaged and the control areas was there was a huge rearrangement of fuel. So in the undamaged areas, fuels tended to be spaced out really evenly distributed, whereas in the damaged area, fuels were clustered tightly together in some areas and really sparse in others. And so if you think about a campfire, it's really easy to see how this rearrangement of the same amount of fuel can lead to an increase in fire intensity. Because you've got fuels clustered close together, the heat from one fuel element can preheat and dry out the next piece of fuel so that the entire pile of fuel can burn more completely and with higher intensity. So that just goes to show that the interaction between wind damage and fire is much more complex than a simple addition of fuel. If we want to understand how destructive disturbances like fire behave, we want to understand not just the changes in fuel amount, but the more complex mechanisms through which disturbances interact. Thank you.